Good morning, everyone. We're going to find the equation of the tangent line to the curve. So in finding the tangent line to the curve, the formula goes as y minus y sub 1 is equal to the slope of the tangent line times the quantity of x minus x sub 1. So the missing values will be discussed by Loreille.
So, based on this equation, what do you think are the variables that need to be solved? When observing this problem, there is no point of tangency, which are y sub 1 and x sub 1 in this formula. But the first step when finding the point of tangency is to determine the anti-value or the slope of the tangent line. But first, you must find the derivative of the curve.
So in finding the derivative of the curve, we're going to use the power rule. From y is equal to 4x squared minus 3x, the power rule will change the equation into y prime is equal to 4 times 2 times x to the power of 2 minus 1 times the coefficient of minus the coefficient of 3. So this becomes y prime is equal to 8x minus 3. So we finished the deviation of this. So the next step would be finding its slopes. In finding its slope, Loreille will explain the equation.
So when finding the slope of the curve, you must first use this formula, which is this. And to determine the anti or the slope of the tangent line of the curve, you must determine the coefficient of the variable x, which is 8. And when finding the slope of the line, you must transpose y and the coefficient of the variable x is the slope of the line, which is 1.
So if we now found the slopes of the two equations, the rule of the parallel line is that the equation goes as the two slopes is equal to one another. So the slope of the tangent line would go as 8x, while the slope of the curve will go as is equal to 1. So the next step of this is we're gonna find the value of x. In finding the value of x, we're just gonna simply divide this equation by 8. So we're gonna divide it by 8. So the answer would become x is equal to 1/8. So finally, we acquired everything that we have. We found our x variable, our slope. So the next thing we're going to find is the tangency of y sub 1.
So when finding the tangency of x sub 1, you use the equation of the curve, which is
we're just going to simply replace the value of x, which is 1/8 in the normal equation, to find the tangency of y.
you substitute the
Value of x.
to the equation of the curve.
So 4 is divisible by 16. We're going to cancel 4. It becomes 1/4. So minus 3/8. So in finding this, we must find the LCD. So it becomes 2/8. 2 minus 3/8. negative 1/8. So finally, we have acquired every missing variable in this equation. The final step is to put all the missing variables to the original equation. So our value for y sub 1 is negative 1/8. Our value for x is 1/8. And our empty is equal to 1. So the equation goes as y plus 1/8 is equal to the empty, which is 1 times x minus 1/8. So multiply it by 1, we will get, and transpose this, we will get y is equal to x minus 2/8, but this is still divisible, so the final answer would be y is equal to x minus 1/4. So finally, we found the equation of a tangent line to the curve. So this is the process of finding the tangent line to its curve. That's all. Thank you.
Wow, huli kayo guys!
Jamal, here we are to find the equation of the horizontal tangent line to the curve of y is equal to x cubed minus 9x squared plus 15x plus 23. And here is Elddie to solve the equation.
So the first thing to do is to get the derivative form of the equation. So we all know that the power rule is y prime equals nx the power of n minus 1. So to get the derivative form of x cubed, we use power rule. So x cubed is equal to 3x squared minus 18x plus 15. And you wonder why 23 is gone there, because we use the constant rule where y prime is equal to c equals 0. So that's why 23 is gone in the equation. So this is the derivative form of the equation y equals x cubed minus 9x squared plus 15x plus 23. So Germuell will try to factor out this derivative form of the given equation.
So in the equation 3x squared plus 18x plus 15, their greatest common factor is 3. So we're going to divide 3 in each term. So 3 times x squared minus 6x plus 5. And with this equation, it's factorable. So it is the product of two binomial terms, which is x minus 5 times x minus 1. So we're going to find x and we're going to transpose it. So it's going to be x equals 5 and x is equal to 1. So with this, we have two x's and we're going to substitute it in the equation. Therefore, 5 cubed minus 9 times 5 squared plus 15 plus 5 plus 23. So 5 cubed is 125. 9 times 5 squared is 225 plus 15 times 5 is 75 plus 23. So, okay, so we're going to add this up. So y is equals to negative 2. With the point of tangency, 5, negative 2. And we're going to substitute x, 1 with the x. So y equals 1 cubed minus 9 times 1 squared plus 15 times 1 plus 23. So 1 cubed is 1, 9 times 1 squared is 9, plus 15 times 1 is 15, plus 23. And we're gonna add this up, it's gonna be 30. The points of tangency, 1 and 30. That's it, thank you.
Find the equation of the normal line with the curve of f of x equals x cubed minus 9x squared plus 15x plus 23 at point 0, 23. So first, we will get the derivative of this to get the slope of the tangent line at any point, which is equals to 3x squared minus 18x plus 15. And next, now that we have the derivative, we will get the slope of the tangent line at point 0 and 23, which is, we substitute x to 0. Equals 3 times 0 to the power of 2 minus 18 times 0 plus 15. It is equals to negative 1 over 50. Now we find the equation of the normal line with Mr. Santes.
So let's gonna find the equation of a normal line. The formula of equation of a normal line is y minus y sub 1 equals mx x sub 1 so which is y 23 equals negative 1 15 x
To x
0. So next we're gonna multiply this and this. 23 equals negative 1 for 15x. So next, let's transpose negative 23 to here. So y equals to negative 1 over 15x positive 23. So this is the equation of a normal line.